Alrighty, here we go for Chapter 16, Section 3, Solar Energy. Very simply, what we're going to look at today, we're going to talk about passive solar energy, active solar energy, and photovoltaic cells. Now, the cost of using sunlight to produce electricity is falling rapidly. New technology coming along, we're getting better and better at making them, and this is good news for everybody. So let's go ahead and jump in and take a look at these. Make sure you keep them separated in your head, you know which is which. First off, we're going to talk about passive solar heating. Now, humans have done this almost instinctively for a long time. This is just arranging your living quarters to take advantage of the sun and where it hits. Now, we know the earth tilts towards the sun in the summer and it leans away from the sun in winter. Well, our houses take advantage of this. This is why we have the eaves. They hang out over our house. This provides some shade. So in the summertime, when the sun is up really high, then the eaves provide shade for the house and the sunlight doesn't come in through the windows, keeping it a little cooler. But in the wintertime, when the sun is low, like you can see in the picture back behind us, then the sunlight is able to come into the window. So what you do on the kind of the south and east facing part of your house, you have big windows, so that way the sunlight can pour in and can naturally heat your house to save you some money. So in passive heating, what we do is we take advantage of big windows in high overheaves, so they shade it in the summer, but they collect the sunlight in the winter, and you have to have really good insulation to trap that heat in. So it's not just the big windows, but you want to have big windows that are good insulators and the rest of the house as well. Smaller windows on the back side so the heat doesn't escape out the back, and etc. So this is passive solar heating, and we have done this forever. Now, not everywhere can take advantage of it. If you're in shady areas, lots of trees, but if you live in an area where you can, passive solar heating. Active solar heating. Now, this is not what you probably think. Active solar heating is where we're using the sun to heat up a liquid of some kind. So yes, up on the roof or somewhere out in the yard, you will have some solar panels, but these are not converting the sunlight into electricity, it's just converting it into heat. It would be a dark black material, and then you run piping through it. Now, we could be warming hot water. In Nepal, this is what we use. We had 4 of these up on the roof, and our water ran through them. So during the day, it heated our water up, and you could wash dishes, take a hot shower, you name it, taking advantage of active solar heating. Also, to warm a house, what we can do is instead of running water through it, you run oil or antifreeze, something that kind of stores the energy. You run it through there, and then you run the piping through the walls or even the floors of your house. And this then gives off the heat. Or you could run it through something like a normal radiator. So it warms up, it runs through this area and provides heat into the house. Active solar heating. We're just heating something up and bringing that warm substance into our house to warm it up. So we have passive solar heating, just taking advantage of putting our house facing the sunlight in the right way. Active solar heating, heating up a substance and then running it through our house. The house back here is taking advantage of both of those. You can see out in the front, they have those solar panels. Those are active heating solar panels. That's actively heating up their water to warm up their hot water. They have, where I grew up in South Carolina, we call them Florida rooms, but this room up front with lots of big windows. So this is an area where it gets the greenhouse effect. The sunlight comes in through the glass and warms that area. So you can have a nice warm room that you don't have to pay to heat. So they're taking advantage of some both passive and active solar technology to warm their water and warm their house. This is a pretty common way of using solar heat. Now, the graphic I have up here now shows North America. Well, in order to make use of passive or active solar heating, you have to have an area that gets a lot of sunshine. So these are the areas. Red being really good, like 80 to 90% of the time, when the sun would be out, you tend to get nice sunny days. The orange is very good. Then the green is, the yellow, I guess, is moving into good. Then it's moving into sort of moderate and low and poor, not so good. Once again, the farther we get tilted away, we don't get as long in the sunshine. And some of these areas are cloudy a lot of the time. Once again, you have to have a lot of sunshine. So 80 to 90% of the red, down to maybe in the 20% to 30% in the dark blue. And when we talk about passive and active solar heating, as with everything, we have these trade-offs, right? Advantages and disadvantages. Well, it's a medium net energy. This is good. Anytime that we're getting in the medium net energy quality, we're very happy with that. These are fairly low cost. As long as you plan out building the house in the beginning, the cost of the house is virtually the same no matter what. But if you take advantage of placing it in the right area, building the eaves and putting the windows in the right locations, you can take advantage of passive solar heating. Very low emissions, okay? It doesn't cost any more to build your house taking use of passive solar heating than to not build it. So it's free as far as greenhouse gases go. There's no other pollutants going out with either of these activities, if you will. Very low land disturbance. Typically, these are going up on your roof, and if you're building your house, the house is going there anyway. So very little to no land disturbance, and it's a moderate cost. Once again, neither of these are particularly expensive to do. They just take a little bit of thought ahead of time. And with the active water systems, a little more expensive because you're buying something to put on your roof, but these are not particularly expensive. So once again, moderate cost at best. Disadvantages, well, you got to have access to sun really at least about 60% of the time. So if you're in a shady area, lots of trees or other buildings blocking out the light, or you live far enough north where the sunlight doesn't come in as much, it's not very effective for you. Sun can be blocked, obviously, by anything else, and you don't always have control. Your neighbor puts up some trees and there you go. It doesn't help. There's high insulation and some maintenance costs. To really take advantage of these, you got to have very good insulation. You don't have very good insulation and the heat just escapes right back out, or it heats up too much, either way. And you have to have a backup system. These are just part of your plan to warm and try and keep your house cool, if you will. You've got to have some sort of backup. It is not the sole only way you can go about it. Now, cooling our buildings naturally, right? They were mainly talking about how do we heat it up? Well, how do we cool it naturally? Well, a lot of this is sort of common sense, if you will. In certain times of the year, open the windows up. Here in Florida, we tend to keep everything tightly closed, but a lot of times of the year, it's quite nice outside. Open the windows, get some fresh breeze. Instead of running the air conditioner as high, turn your fans on. The moving air helps things cool, and it's much cheaper to use. Super insulation. Make sure the house is insulated. This saves money on both ends, if you will. Taking use of shade trees. Even in the passive heating, if you use a deciduous tree, the leaves fall off, right? Especially if you're in an area where this occurs. Well, in the summertime, you get shade from it, and in the wintertime, it drops its leaves and you get the sunlight. So once again, taking advantage of nature for cooling as well as warming. Using a light-colored roof. A light-colored roof can reflect up to 90% of the sun's energy, where a dark-colored roof is going to absorb most of it. It's only going to reflect maybe 10 to 15%. So depending on where you live, if you're in a farther north climate, you may want a dark roof, but if you're in a farther south climate, you really want a lighter colored roof. And then you can take advantage of geothermal heat pumps to bring cool air from underground. Piping from under the ground normally stays around 60 degrees year round. So in the wintertime, if you can bring your house up to 60 degrees, it can help warm it. Once again, it's not going to be the whole thing, but it'll help. And in the summertime, if you can bring 60 or even 65 degree water circulating through your house, then you can help cool it. So taking advantage of geothermal is also a way that we can cool, because the ground normally stays cooler no matter what. Now, another thing that we can do is take advantage of this active solar heating by concentrating the sunlight to produce high temperature heat, therefore electricity. You get high enough temperature heat, you boil water, we get steam. Steam can spin a turbine, and we can generate electricity. So we use some of these solar thermal systems, like you can see back here. What we're doing is we're collecting the sunlight. So in this array out in the Mojave Desert, those aren't solar panels, they're not generating electricity, they're just reflecting the sunlight back to a concentrated point right at the top, which heats up the water, causing it to boil, generating steam. We generate electricity. We use these in deserts and open areas that get a lot of direct sunlight. We can take advantage of it. Now, unfortunately, it does require very large volumes of water. We have to condense the steam. Steam is hot. You got to put the steam through cool water to condense it back in so we can keep using it, and you have to keep the mirrors clean. And unfortunately, a lot of times these are in deserts, areas that don't really have lots of water. So it takes high volume of water, and a lot of times the areas where these work the best, we don't have lots of water readily available. And currently we're still getting some low net energy yields. They work, they function, and it's kind of part of a system, if you will. It is not the only thing we can utilize, but they are adequate. Now, some of their advantages and disadvantages, again, there's a high potential for growth here. Our technology is really picking up steam, if you will, in this area. We don't have any direct CO2 emissions. When sunlight directly into the heat to boil the water. We're not having to burn oil, coal, natural gas, anything of that nature. And there's lower cost involved, especially what we do is sometimes we use some gas turbine backups. So it's generating it from the sun when we can, and then we can go to some other kind of backup, and that keeps the cost a little bit lower. And this is a source of new jobs. These are things that are being created, so people come out, build them, put it together. A lot of new jobs, a lot of good advantages. Disadvantages right now, it's still a low net energy. It's high cost to build it, and we're not getting as much out of it as we are, say, with a natural gas plant. That's still in the medium variety. It needs a backup system. Obviously, if it's cloudy or at nighttime, it's not generating any electricity. So it's part of the electricity for a grid, but it's not the entire system. It requires high water use, like we talked about, and it really can be disruptive to desert systems. All right, let's talk about using solar cells to produce electricity. This is what you and I, we tend to think of a solar panel, what we call a solar panel. This is where the sunlight is generating electricity directly. This is called a photovoltaic cell, or a PV, photovoltaic cell. It converts solar energy directly into electricity. What happens is the sunlight hits these cells and it produces a flow of electrons. We use some semiconductor silicon in these, and as the sunlight hits it, we begin to get a flow of electricity. Now, we usually have to make them pretty big because you get a very small flow out of a small area. But as these electrons begin to flow, we have an electrical current. And these systems can be connected into the current or existing electrical grids. And a lot of times, this is really what you do in a house. You put your solar panel up and you're tying directly into the grid. And they're just metering how much energy you're producing. So let's say you use $250 of electricity a month, and your solar panel produces $230 of electricity that month, and your electric bill is $30. You know, it's just, you're just paying the difference. So you're generating electricity for the power company, and they're kind of paying you for your electricity with your electric bill, takes it out. But this is how that normally works. Now, these solar cells are really getting super thin these days. 15, 20 years ago, they're really thick, they were very expensive, and they didn't generate as much electricity. Well, now, because of nanotechnology and some other emerging technologies in the field, they're super thin. They can be rigid and even flexible sheets. You can take it, kind of roll it out. I use these for charging cell phones out in when I'm camping, etc. You just roll these things out and get your electricity from them. There's also expanding use of these going into rural areas. You see the picture back here, the people in West Bengal, India, and they're leapfrogging technology. Instead of having all the electric grid and power lines and wires having to come into their house, they didn't have electricity in this area, and they're bypassing all of that expense and going directly to a solar panel up on the roof. Solar panel goes up on a roof, comes down into some LED lights, which are very low energy, and you tie into a battery system in the house. So the solar panel charges the battery all day long, and they're getting electricity during the day. Then in the evening, when the sun goes down, the battery power will power their LED light bulbs and other small electronic devices till it's time to go to bed. So a lot of places in rural areas can completely leapfrog the technology, and we can even go in to make these solar-powered microgrids. Having the solar powers up and enough just for a small community. And another one over there, instead of one big grid for everybody, more of this like smart grid technology. For instance, if you look at the picture back here, this is a town in Germany, and everybody up in that town has solar panels up on their houses and homes, and they're getting the majority of their electricity from the solar power. Goes in and helps charge a battery, and then they have a smaller coal-powered or oil, natural gas plant as the backup. But this is providing most of the power to the village, and they're only using a fraction of the fossil fuels to continue it along. When it comes to using solar cells to produce electricity, just like everything else out there, it has its trade-offs, right? Its advantages and its disadvantages. So let's address them real quick. Advantages: very little to no direct emissions of CO2, pollutants or any other pollutants, greenhouse gases, you name it, in manufacturing and transporting. But once it's up and being used, no pollution, no CO2. Very strong advantage to it. They're easy to install. Let's take a look here. These are sample ones we use in class for lab various. This is an old one. This is about 10 years old from Shell Solar. And this is a newer one that we get, thinner, etc. This one has a much higher productivity than this one. This one winds up getting a little bit of shade, and its power kicks down tremendously compared to this one. Even though very similar in their looks, technology has gotten much, much better, but they're easy to install. Now granted, these are small. This runs about 1.5 watts, if you will, I guess up to about 3, a couple of batteries. So this would be enough to power a small toy, if you will, but you can link them together. This is what we get up on our houses, etc. So they're easy to install, they're expandable, you can move them around. I need more, I just stack more up. I want to move them somewhere else, I actually sell my house. Well, I could either choose to leave it there, or I could take them with me wherever I go. So the aspect of their ability to either use more of them, their ability to stack up, is a strong benefit. They're a competitive cost with the newer cells. Now, once again, as we go, if I had these older ones, it would take a lot more of them to get the same energy output as this one, even though they're a similar size. When we talk about getting our newer cells, they are much more competitive costs. When I'm talking about, do I want to invest in them to get the electricity out? It's a pretty easy deal these days. Also, a lot of companies will work with you. So let's say it does cost me $200 a month in electricity. Well, it's expensive to put the panels up. Well, you know what? They'll make a deal. They'll say, all right, we'll let you buy it for 8 years. It'll cost you $200 for 8 years, but I'm getting $200 out of it. So there's no net cost because I'm getting $200 in savings off my electric bill. So in a sense, I'm paying the same amount, but at the end of 8 years, now that's $200 in my bank account every month. Not that it would take 8 years, I'm just throwing a number out there. So you could finance them for 5 years, you're paying the same amount of money. There's no net cost to you, but after 5 years, it's all savings money in the bank. So a strong benefit to them. Disadvantages, well, you have to have access to the sun. Right now, I could hook it up to a little voltmeter, but we wouldn't see anything. It needs to get the sunshine to really work. I might be able to pull down a few watts here, but not enough, or a few volts. But once again, I only get about 3 volts off of this one, And in here with the lighting I'm getting, I might get as much as a half volt. So you do have to have access to the sun. Shady area, blocked out by buildings, what have you. And if it's a cloudy, rainy day, you're not going to generate it. You need some sort of storage system. Now, I could rig this into a battery and I could charge the battery. A lot of our ones that work at night, like I have a few out in my yard with a solar panel, and then at night they pop on. What they're doing is they're just going to a rechargeable battery, and then at night the light's running off of the rechargeable battery. So you have to have some sort of backup system, but these can charge a battery, and then when you get home and the sun goes down, your house kicks over into the battery, or you can feed directly to the power station. Different ways to go about it. But you have to have some sort of backup. You can't count on this 100% all of the time. Right now, it's a low net energy, but that is likely to expand. It's probably going to go up to mid-level energy, which is really what we're after in the next decade or so. The solar cell power plants could disrupt desert ecosystems. You know, once again, we start putting entire fields of these, well, there is some possible land degradation. We're not mining it, we're not tearing it up, but if all these things are out on a field, we can't use the field for something else. Putting them in the desert can mess up desert ecosystems. If we're putting them in cropland, we can't grow crops. So they need to be in places or not, but up on a roof, perfect spot for them. Guys, that wraps it up for solar cells, whether we're using solar to get passive, solar to get active, typically heating liquid of some kind, or we're getting solar to generate electricity. All good things to look at, places to go. Come back next time and we'll look at wind energy. See ya.